Good morning, everyone. Since there are just a few of us, we just wait at 8:05, I think. Then I'm gonna start. Okay, it's 8:05 a.m. So good morning, everyone. We think we just start. So today the topic will be about comparative statistics part two. This will be the continuation of what Dr. Lizan has told us in the previous part one. So this is the continuation. So today we're gonna focus on Mann-Whitney U-test, Kruskal-Wallis test, Wilcoxon sign rank test, and Friedman test. So we're gonna go into each of them later on. So before we start, again, I wanted to remind everyone on the a pleasant steps for your journey of be it preparing a thesis, completing a project, or even for academic stuff, or writing your paper. So when you first start a project, you have to, so this is focusing on the stats analysis bit. So when you first start a project, you have to identify your variables of interest, and you have to make sure that your variables is based on your study objective, and those variables are answering your objectives. Then even before you start your project, you can start on preparing an empty SPSS template data sheet, so that you can have an idea of how it will be inputted in the SPSS later on. Then you can start collect your pilot sample. This is up to you. If you wanted to do some pilot sampling, you can do that. Some of you may have a solid literature review, and then based on that, you can calculate your sample size comfortably. Then that is fine. But for those of you who don't have any source of prior project to refer on to, so probably you want to do some pilot sampling. So from this pilot sampling, you can try to come up with your expected number of recruitment. Then you can try to, based on your pilot sampling, even though you don't do your pilot sampling, but let's say you just straight away goes into your data acquisition. So you may want to put your first few of your data into the SPSS sheet, just to have a feel of what your data looks like. And then you can try to do some simple analysis to see that whether it makes sense or not. It's also good to assign all those variables into the correct types. For example, continuous variable, you put in as not as string, and things like that. So then only then, after you have comfortable with your preliminary data input, then you can continue sampling until the very end. You can do your cleanup and analyze your data. Okay, so a little bit of revision. You have to know every time, like before you wanted to do your analysis, you have to know your skewness, your distribution of your data, whether it's skewed, whether it's symmetrical, because this is important for you to decide which test that you would want to use later on. So as you can remember, as a revision, if it's sort of symmetrical, then you want to use mean and SD. Whereas if you have a skewed data, you may want to use median and IQR instead. So based on this skewness of your data as well, you're gonna have to choose the correct tests. For this case, we're gonna focus on the comparative statistics. So if you want to compare two population, two groups of data set that you have, case versus control, treated versus non-treated cohort, for example. So you want to check the skewness before you can select the appropriate test. Okay, this was, I just took a screenshot from what Acadesian has provided previously. So this is the summary of the process. Once you have your variables, you have to know whether they are normally distributed or not. If yes, and if it's equal size, you can take those parametric tests. If it's not normally distributed or not equal sample size, you're going to go with non-parametric tests. So all these, just want to inform you that all these prior, not all, but some of the prior recording has been uploaded at the link down below. So you can refer there. All the slides of prior lectures also will be there, so including this one. So you may want to refer there as well. Okay, another revision page. This is like, I think this is a very nicely put summary to help you on selecting your correct type of statistical analysis. So of course, you have parametric, non-parametric, based on whether it's symmetrical or non-symmetrical distribution. And if you have two groups, you have certain tests. If you have more than two groups, you have certain tests. So this is a very good representative cheat sheet, the same cheat sheet for your analysis. You can keep this for your future references. Okay, so last time Dr. Lizen has highlighted the parametric tests. Today we're going to focus on the non-parametric side, which is Mann-Whitney, Wilcoxon, Sandbrand test, Krusker, Wallis, and Friedman. Okay. So first, Mann-Whitney U test. So the purpose of Mann-Whitney U test is, of course, to compare the median between two independent groups. So, for example, if you have, say, it's either you have, let's say, you have a cohort of asthmatic children versus cohort of children without asthma, for example. So you want to check your exacerbation, for example, in terms of numbers of things like that. So you get what I mean. So if you want to compare between the two groups, you compare using Mann-Whitney if it's non-parametric. So another example, if let's say you just want to measure the height of female versus male, so that kind of thing. So it's quite straightforward. This one, I think most of you know about this. Just that you have to know which one to select based on the distribution of the data. So how to do in SPSS? So first, after you have cleaned up your data, put in all those nomenclature of your data, basically types, make sure the quantitative data is not in the string format, things like that. So once you have done that, you clean up all the data, then you can try to analyze. So first you press the analyze, goes to non-parametric test, and then two independent samples. So this screenshot is based on the Windows version. I think this one is version 18. Even if you use the latest one, it should be about the same. If you have Mac as well, it should be about the same, but probably there's like a step. It's a non-parametric test, and then is hidden under legacy, for example, legacy test. So you can find that. So that's just a little bit on Mac, a bit of a different UI, let's say. So it goes to two independent samples for Mann-Whitney U test. Then you can put your continuous or ordinal parameters. So just to mention as well that you can use ordinal parameters to compare. For example, let's say you have let's say severity of a disease. Let's say grade 1 and grade 5. Let's say the COVID, right? You have a category 1 and category 5. So you can compare that ordinal type of data between two groups as well using this Mann-Whitney test. So only for non-parametric. So parametric, you cannot use ordinal. Okay. So once you have put your variable, so you put your continuous variable or ordinal parameters into the test variable list. Then you put your categorical parameter. This is your grouping that you wanted to do. For example, here I put in weight and age, and then put in gender. So you once you have put the gender, you can press define groups, and then you assign which group that you wanted to compare. Let's say, for example, okay, for gender, probably you code it as 1 and 0. Let's say you have ethnicity. You're going to have 1, 2, and 3, for example, Malay, Chinese, and Indian. You want to compare only Chinese versus Malay, for example. So then you can do so by denoting group 1 is 1, group 2 is 2, which means you're comparing Malay versus Chinese. So it can be done as well. So this is again Windows version. I think if you use Mac, you don't have to assign the groups like this. So it's a little bit different, but it's about the same. Okay, so make sure the Mann-Whitney U is ticked. Then you can press OK. Okay, so this will be the output in your SPSS output window. The top here is the summary, so you can see the overview. You have 16 and 15 data with weight, and then you have 79 female and 65 male that have data on age. So the SPSLs will calculate the p value based on whatever data available. So those data that are not there, so basically it's a missing data, it will not be counted here. The SPSL automatically excluded those. Okay, so that's why it make sure when you input your data, let's say you don't have weight for certain people, you leave it as empty. So some people like it to put as 99999. You can, but you have to assign those 99999 or whatever the number that you have as missing data. So you have a step before your analysis. But if you just leave it empty, basically it will show as a dot. So SPSS will automatically exclude those data, those missing data. Yeah. So what you want to see is this row asymptotic significance to tail. So here you can see that the weight is significantly different between male and female, but not the age. Okay. We're just going to focus on this row. There are a lot more things to consider about exact significant one tail significant. This one is actually will automatically appear if you have your data less than 40. So here you can see the weight. The pairing is the pairs are less than 40, so they will automatically calculate this one. So it's not too important, I think, for your purpose. You just take the asymptotic significant for your case. Okay, so next is Kruskal-Wallis test. So the purpose of this test is to compare the median or ordinal parameter again between more than two independent groups. So you have 3 or 4 groups, and you want to use this one. For example, again, if you want to check the height of Malay versus Chinese versus Indian, Malay versus Indian as well. So it will calculate. We will give you a one p value, which denotes that among these Malay, Chinese, and Indian, there are significant difference, but you cannot know which one yet from the Kruskal-Wallis test. You don't know which one is the significant interaction. Is it Malay versus Chinese is the one that's significantly different, or Chinese versus Indian, or so on. So you don't know yet. This is sort of like a pre-hoc test where you want to see whether there are any difference. If you want to check whether which one that gave the difference, later on we can see what you can do with that. Okay, so for example, another example that if you have a questionnaire based essay, for example, you have a Likert scale to check on the happiness level. For example, patient from the B40 family versus N40 versus T20 family. So you can do this as well because ordinal is okay for this non-parametric test as well. Okay, so how to do that in SPSS? First, analyze, goes to non-parametric tests, and then K independent samples here. So again, if it looks slightly different in your version, you try to find it under the legacy test. Okay. Okay. Then you can put in your continuous and ordinal parameters or ordinal parameters into the test variable list. See just a similar thing. Then you can put in your grouping variable. So again, if you have, let's say, 5 groups, but you only want to compare 3 groups, then you can denote here which one the range. Let's say you have group 1, 2, 3, 4, 5. You want to compare between group 1 and 3 only, you can put such 1 to 3. So if you want to compare like 1, 3, and 5, then you cannot do that. So you have to decode it so that it will be okay. Unless you use the non-legacy bit, but I think most of you are more comfortable with this one. So I think most of you don't have the latest version. So I think this will be the most representative for most of you. If you have the latest version, similar, but it will be simpler. Okay. So after you define your grouping variable correctly, then you can press OK. And then this will be the output. Again, similarly, you have the summary up here, and then you will refer to your asymptotic significance. So in this case, none of them are significantly different. But let's say you have H as significantly different, 0.001. It doesn't mean that you know what are the specific group that gave you the significance. So it's just gonna say that one of the group are significantly different from the other. So you don't know which one yet. So how do you want to know? How can you know which one? Is by so typically if you are using I think like 18 version 18 and below, you have to do, unfortunately you have to do manually. You have to check manually. Use man with me and then check the multiple variation of group that you have. You have to compare manually. But if you have the recent version, including the math version, you can automatically get which group that are significant by clicking this test statistic table, and then goes to the model viewer. So once you click this model viewer, there's a drop-down menu. You can select there post hoc. Then you can see exactly which group that are significantly different. Okay, so I cannot show this because I also using the old version. Okay, so but I think it's quite straightforward. You can try to see the step. Double click the test statistic, open model viewer. At the bottom right, there will be a drop down menu. You can select a post hoc to check which one is the significantly different group. Okay. Okay, next is Wilcoxon sign rank test. So this one is okay. Just now is independent. So those two, Man Whitney and Christopher Wallace, are independent. So basically, they are not related. They are different sample, different group of sample. Whereas these next two tests will be paired sample. They are related sample. So, for example, you have a cohort of let's say leukemic patient. So you want to check the blast count before and after chemo. So within the same patient, it's just that the timeline is different, before and after, or at the presentation and then 3 months later, things like that based on your project. So whenever you are measuring the same thing within the same patient, just at different time point, you may want to use this one instead. Okay. Okay, how to do this in SPSS? Similarly, analyze non-parametric test, but then this time you choose two related samples. Okay, two related samples. Then you can put your continuous parameters that you wanted to do. For example, here, okay, you have variable 1 and variable 2, which means okay, pair 1. So pair 1, basically, let's say you want to check the height. Okay. Okay, we take back the example here. Blast count before chemo and after chemo. Okay, so let's say this pair 1 is where you want to check the blast count. Let's say pair 2, you want to check the neutrophil count, for example. Okay, so the variable 1 here is the pre or before chemo blast count, and then variable 2 will be your post chemo blast count. For pair 2, if you have, for example, the triple count is a pre-count and then post-count. So it goes into row. Okay, pair 1, pre and post. Okay, all right. Then just make sure to tick the Wilcoxon, and then you press OK. That's the default one. I think most of you will fall under the default setting. Okay, so this is the output. I think you can ignore the top half. It's just basically highlighting whether They just want to compare pre versus post. What happened to the post? Is it post increase? How many increase? How many decrease? So you don't have to focus that too much, but you can just take this one for example, the asymptotic significant here. So this highlight that there are significantly different between the post over pre. Okay, so significant different. Okay, so um, if you have tak apa, this one later. Okay, so next is Friedman test. This is where you have 3 or more groups. So similarly, this is the equivalent of Kruskal-Wallis, but for PET sample. So let's say this time you want to check the stress level before treatment, during treatment versus after treatment. You can do that. Or so this one is based on the different time point. We're measuring the same parameters just at a different time point. You can also, for example, you want to measure CRP level, systemic inflammation marker. You want to check the during the same time point, method A, method B, method C, for example. So you can do that as well. Depends on your objective. Okay, so you can do either. Okay, so similarly, analyze non-parametric tests, kill related samples, and then put in your data. So this time you have 3, current, and post. Okay, for example. Yeah, so make sure Friedman is ticked and then press OK. Then you can see that that p-value highlighted here under the Friedman test. So here again, denoting that one of the group are significantly different, but you don't know which one. This is a similar case of the Kruskal-Wallis where you don't know which one. This is an omnibus test. So okay, so you have to do to compare manually. Okay, so just to highlight here, okay, I put in the box here. So if let's say actually if you do manually your post hoc manually, Kruskal-Wallis and Friedman, I think I put wrongly here. So once you put once you calculated manually, for the purpose of getting which one is the significant test, if you have 3 or more groups, you have to do some sort of post-hoc adjustment as well. So the most easiest way is to do Bonferroni adjustment. So for example, at the start of your project, you say 0.05 is your cut-off value for significance. But once you do any post-hoc test, like manual manually to get 3 or more groups, then you have to do some adjustment. Whereas now your cut-off value is now are much lower than 0.05. So let's say you have 3 groups is now, let's say pre, current, and post. Then you're gonna have 0.05 divided by the unit test. So 0.05 divided by 3. That is your new cut-off for this, only for this manual manually test. But if you have the SPSS automatically generated for you, that one is already transformed. So you can just take that one as it is. Okay. So okay, again, so this is the summary. Based on your type of data distribution, whether it's skewed or not, you're going to select the appropriate test. If you have a symmetrical, normally distributed data, you're going to take the parametric test based on whether it's independent or related, and based on whether you have 2 or more than 2 groups that you wanted to compare. So this is the table that you want to refer. I think. So again, if you have any question, you may contact us. If you want to refer to any prior material, you can go to the link here. So you can scan or copy this link. Yeah, so I think that's all for today. So if you have any question, I'm happy to answer.
Hi, Shafiq. Justin here. Can you hear me?
Hi. Yes, I can.
Hi. Yeah, just a quick one. Just an example. The Friedman test, right? Where there's these three groups, right? In related three groups. To determine which group is the one that is significantly different, could you also use the Kruskal-Wallis test and test to the pairs, like example, the Malay versus Chinese, Chinese versus Indian, or Malay versus Indian using the Kruskal-Wallis? Does that work, or it doesn't make sense?
Friedman usually meant for paired sample. So if you have independent group, like you mentioned just now, Kruskal-Wallis is correct to use. But let's say you have, for example, height across 3 time points, then you want to use the Friedman instead. So it depends on the nature of your data, whether it's paired or independent. So the one that you mentioned, Malay, Chinese, Indian, yes, Kruskal-Wallis.
Okay. No, what I meant was like we said, where the 3 samples, right? Sorry, let's say the 3 related sample, the 3 paired samples.
Okay.
If you don't know which one is the one causing the significance, could you use the one that the other 2 tests, the one you talked about,
So if for Friedman, you want to check which one is the one that's significant.
Yes.
Yes. Okay. So you use the Wilcoxon sign rank test. So this is the
yes. Okay. Yes. That's what I meant. Sorry, I used the wrong one. But yeah, so you could use this Wilcoxon to check which 2 are causing, which 2 is the one that is causing the significant difference within the 3 groups.
That's
okay.
right.
Yeah. Great. Thank you.
Sure. Any other question? Post the recording here. Slide and recording here. You can just go to the link. Okay. This is the link. Can I do that here? Okay, I just copy the link and then paste here. Okay, I pasted the link here as well. Okay, Dr. Faisal Amir. So the recording of today's and the slide as well will be uploaded there as well later on. Okay, any other question? All right. So again, if you have anything to ask, there's always you guys can contact us. Okay. Start my mail.
Shafiq, how long will the videos be on the website for? Is it permanently there, or there's a certain time? Okay.
Permanently.
That's great.
Yeah.
Thanks.
All right. Okay, our email here, so you can contact us if you have any questions. So, okay, that's all. We're gonna end here. Thanks, everyone.
Thank you.